Now, I will follow the labeling convention that was discussed in previous videos. The three sides are denoted by the small letters A, B and C. Capital C, this angle, is opposite the side of length small c. The area of this triangle is half A times B times sine C. In words, it's half the product of two sides of a triangle times the sine of the angle in between the two sides. So we need any two sides of a triangle. We can call them A and B. And we need capital C, the angle in between the two sides. Let's look at this example. Here we have a triangle. We have the two sides and the angles and the angle in between, so we can find its area. So you can label the sides and the angle if you like, although you don't have to. You can call one of these two sides A and the other one B. It doesn't matter which. I could call this one A and this one B. Then capital C is the angle in between them. Small c is this side here. Small c doesn't come into the area of a triangle. So what do? We take half the product of the two sides, so half A times B. Okay, so we're multiplying everything here. And we have to get the sine of 30 degrees. If you work this out, you will get 15. Now, if these lengths are in meters, then the area will be meters squared. Now, let's suppose that we know the area of this triangle, but we don't know this angle. So I'll do the reverse problem. It's straightforward. Let's suppose that the area of this triangle is 15 meters squared. I will write 15 meters squared in here, and we have to find this angle. So we half the product of the two sides times the sine of the angle in between. We'll just call it capital C. We don't know what it is. And we know that this area must work out to be 15. So what do? Well, we divide 15 by a half times 10 times 6. Well, half times 10 times 6 is 15. I'm sorry, it's 30. So we have 15 divided by 30, which is a half. And if you get the inverse sine of a half, you will get 30 degrees. The only other variation is when you're given the area of the triangle, one side and an angle, and you have to find the other side that contains this angle. Well, this is straightforward again. The area is a half the product of the two sides, so we call the missing side A. The other side is 6 times the sine of the angle in between. That angle is 30 degrees, and this must work out to be 15. So it's only a simple matter of dividing across here. The sine of 30 is a half, so we have a half times 6, which is 3. The sine of 30 is a half, so 3 times a half is 3 halves, so we end up getting A times 3 halves, or 3 halves A equals 15. And we have 15 divided by 2/3. Well, that's the same thing as 15 divided by 3 halves is the same thing as 15 multiplied by 2/3. So 15 divided by 3 is 5, 5 2s are 10. You get 10 meters. Let's just quickly run through a proof. You probably won't need to know the proof. But anyway, I'll just spend a minute or two on it. Won't take long. Let's just draw in this perpendicular. This is a perpendicular height of the triangle. Let's say that this distance is h. We know that the area of a triangle is half times the base times the perpendicular height. So if we take this side as base, so this distance is b, we have a half the base times the height. If this is the base of the triangle, then this distance here is the height. Okay, so that's a formula that involves the perpendicular height. Now we want to get rid of the perpendicular height. So we need to consider this right angle triangle here, which contains angle C. We can see that the sine of angle C is the side opposite C, which is this length here, small h, divided by the hypotenuse of this right angle triangle. Well, what's the hypotenuse of this right angle triangle? Well, we can see that it's this side here. It's A. It's the side opposite the right angle. It's the longest side. So we're looking at this right angle triangle now. The sine of C is h over A. So we can get h in terms of small a and sine C. So we just multiply both sides by A. And what we do then is we look at a half the base by the height. That's the area. Half the base by the height. But we plug in a sine c for the height. So a sine c goes in for h. And there we have it. The area is half BA sine C, or half AB, doesn't matter, BA, AB, same thing. So we have half the product of the two of the sides times the sine of the angle in between the two sides. So we need two sides and an angle in between to get the area of a triangle. So using this formula, we don't need to know any perpendicular height.